Hey guys, here is a doodle notes for quadratic formula. So this is the quadratic formula. X is equal to negative b. This is plus or minus the square root of b squared minus 4ac all over 2a. It is important that you include this top part together. Then you divide that whole quantity by 2a. So quadratic formula looks like there is a lot of it to memorize, and you're probably wondering why you would ever use it instead of factoring. Well, this comes in handy when your quadratic formula or quadratic function is not factorable. So, if it doesn't have nice pretty roots that you can set equal to 0 and solve using the zero property, then you're going to have to use a quadratic formula. So, you should try to memorize this. That's why there is a song that you can memorize to help you remember the formula. It goes to the tune of Pop Goes the Weasel. So I'm going to write it down, and then I'm going to play you a version of it. I'm not going to sing it because I am not a good singer. So, once you get this into your head a couple of times, it will be stuck there. And you might ask the 8th graders from last year, or for this year, if they remember it, because they will probably remember me playing it for them in class. So it's x equals negative b plus or minus the square root of b squared, don't forget that squared, minus 2a all over, all over 4ac. Wait a second, I'm all messed up. So it's b squared minus 4ac all over 2a. So I'm going to play you the version where it's got harmony, so it's really stuck in your head.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So hopefully you get the gist of it, and that helps you memorize the quadratic formula. So it says, where does a, b, and c come from? Hopefully you remember the general form of your quadratic function. Have f of x is equal to ax squared plus bx plus c, where a is your leading coefficient, and c ends up being your y-intercept. So that's where the a, b, and c come from, and it's important that this has to be equal to 0 and not a constant. So now, let's try it. I've got 4x squared minus x is equal to 3. Our first step should always be set my equation equal to 0. Let me blow it up here. So I'm going to subtract 3 from both sides, and I get 4x squared minus x minus 3 is equal to 0. So now I'm going to identify a, b, and c from standard form. So my a is equal to 4, b is equal to negative 1, and c is equal to negative 3. Now I'm going to substitute and simplify. So here's where my quadratic formula comes in. X is equal to negative b. So remember, my b is negative already. So I'm going to put it in parentheses. Have negative b plus or minus, and then it's going to be the square root. got b squared, so negative 1 squared, minus 4 times a times c. Notice how I use parentheses? That is just to make sure that everything comes out nicely. And it's all over 2 times a, which is 4. Now I'm going to substitute and simplify. So the first thing I need to do is negative times negative 1 is positive. Then plus or minus. Now I'm going to start simplifying underneath my square root. So negative 1/2 times itself, negative times a negative is a positive, so that's a positive 1. It's going to be minus, and then 4 times 3 is negative 12, and then negative 12 times negative 4, remember a negative times a negative is a positive, so you get 48. And then, so it's going to be a plus 48, but you should see something coming together underneath that radical. And it's all over 8. So now, I've got 1 plus the square root of 49. That should be ringing a bell in your head. That is a perfect square. So I've got 1 plus or minus, don't forget that plus or minus 7, all over 8. So now, I can split this, I kind of ran out of room. I can split this into 1 plus 7, which is 8 over 8, which is 1. Or I can make it 1 minus 7, which gives me negative 6 over 8, which gives me negative 3/4. So my answer for this, I've got x is equal to 1 and x is equal to negative 3/4. That is my answer for my quadratic equation. So notice that that would not have come out as a nice, pretty, factorable form. So that's why I had to use a quadratic equation. Sorry, that got kind of messy. So now I have x squared plus 1 is equal to 2x. Do one more practice problem. So remember, the first thing that you do is you set it equal to 0. So notice here, instead of just being a constant, it is a coefficient and a variable. So I'm going to subtract 2x from both sides. I've got x squared minus 2x plus 1 is equal to 0. Notice how I have kept in line with my general form or the standard form, and my linear term is in the middle. My quadratic term is at the beginning with my leading coefficient. That's important. So now, I'm going to identify my a, b, and c. So a is equal to 1, b is equal to negative 2, and c is equal to positive 1. And I'm going to plug or substitute that into my quadratic formula. So, x is equal to, use a different color. Then I have negative b plus or minus the square root of b squared minus 4 times a times c. And don't forget to divide that by 2a. Now I'm going to start simplifying. So a negative times a negative is a positive, plus or minus. Negative 2 squared ends up being positive 4, minus 4, and then, I made my radical way too long, all over 2. I'm getting all kind of messy here. So 4 minus 4 is 0. The square root of 0 goes away. So I have 2 plus or minus 0 all over 2, which I can have 2 over 2 is equal to 1. Notice if I add a 0 or if I subtract a 0, that doesn't change anything. You only have one root, so x is equal to 1. So the first example, we had 2 roots, and the second example, we only had 1 root. Now we're going to talk about something called the discriminant. The discriminant is what is underneath your radical. So it's b squared minus 4ac. That is your discriminant. And if you look at the discriminant, it can tell you how many solutions or how many roots your quadratic formula will produce once you carry it out. So you remember that your discriminant, like I just said, is b squared minus 4ac. Oops, I forgot my c. So if I had this first quadratic function here, 2x squared plus 3x plus 4. This is b, this is a, and this is c. So b squared, so 3 squared, minus 4 times 2 times 4. Let's see what that gives me. So 3 squared is 9. 4 times 2 is 8. 8 times 4 is 32. So 9 minus 32 ends up being less than 0 when you have a discriminant that is negative. You have two complex solutions. A complex solution has imaginary numbers. So that's a conversation for another day. But if you have a discriminant that is less than 0, you have two complex solutions. Now, if your discriminant, once you figure it out, is equal to 0, so here I have a, b, and c, b squared, negative 8 squared, minus 4 times 1 times 16, equal to 0. Negative 8 squared is positive 64. And then 16 times 4 is 64. So that does equal 0. Whenever you have a discriminant that is equal to 0, you are going to have one real solution, which is what we've been used to seeing. So for example, in our last problem, underneath my discriminant, this equals 0. And I ended up having only one real solution. The last thing that you may deal with is a discriminant that is positive or greater than 0. So here I have a, b, and c. And then b, so I got 5 squared minus 4 times 12 times 4 is greater than 0. And then I got 25. 12 times 2 is 24. So 4 times 48, I don't know what that is off the top of my head. 4 times 48 is, I don't know, my laptop's being slow. 192. Wait a second. Something's jacked up here. Got 12, so b squared minus 4 times a times c. So something's off here because 25, 12 times 4 is 48. Something's off here because you should get a number that's greater than 0, but you don't. So let's forget about this function and just talk about what happens whenever you have a discriminant that is positive. So a positive discriminant tells you that you are going to have two real solutions. So, for example, if we want to use our example right here, so if I take the discriminant, use a different color here, discriminant, which is b squared minus 4ac, got negative 1 squared minus 4 times 4 times negative 3. This gives me 1 plus 12 times 48, which is 49, which is a positive number. So positive discriminant ends up giving you two real solutions. So that is a helpful way to identify how many solutions you will get whenever you use the quadratic formula. So hopefully this has found you well. If you have any questions, be sure to contact